Hi everyone, today I'm working through this 6-part question which requires us to work with recursive formulas, geometric series, mathematical induction, and my favorite topic, spreadsheets. So it's an interesting question. As usual, I'll work through each part one video at a time so you can just jump straight to the bits that you want to focus on. So the question tells us that we're given the recursive definition f0 equals 20 and fn equals 4 of fn minus 1 minus 1. So there's the recursion because the function at the value n is a function of what that function was at the value n minus 1. So the first part of this question wants us to write expressions for f1, f2, and f3, all in terms of f0. And we're told to expand each expression but do not evaluate any products or exponentials found. So for example, we'd leave 4 times 5 times 5 as 4 times 5 squared rather than evaluating it. So yeah, let's kick off with this part 1. So we're told that f0 is equal to 20, and we're also told that f of n is equal to 4 of f of n minus 1 minus 1. So we want to know f1, f2, and f3 here. So if I start with f1, that's just going to be equal to 4 times f of 1 minus 1 will just be 0, since 1 minus 1 is 0. So 4 times f0 minus 1. So that's f1, pretty straightforward, hopefully. F2 would be equal to 4, going back to our definition of 2 minus 1 is 1. So 4 times f1 minus 1. Now we've just worked out an expression for f1. So let's insert that. So that would be equal to 4 times, and I'll just put this in brackets, our expression for f1 was 4f0 minus 1. And then we've got the minus 1 on the end. And you can see that by doing this, we're going to end up with everything in terms of f0, which is what the question wanted. So if I just expand this, again, rather than do 4 times 4 is 16, as the question tells us, it wants us to instead leave it without being evaluated. So I'll write that as 4 squared times f0 minus 4 times 1 is 4. And then minus 1. And again, I'm not going to evaluate that minus 4 minus 1. We'll leave it unevaluated. So that's f2. Now for f3, which is the last one we're asked to find, we'll have our definition as 4 times f2 minus 1. And again, we'll insert f2, what we just evaluated in, so that we can get everything in terms of f0. So that would be equal to 4, and then in brackets f2 we can write as 4 squared f0 minus 4 minus 1, and then with our minus 1 on the end here. So if I expand that, we end up with 4 cubed f0 minus 4 squared minus 4 minus 1. And I believe that's all we need to do for this first part. So it's kind of easing us into the question. We're just getting our head around this recursive formula, and we've just worked out just the first 3 ways to represent the function, all in terms of f0. So we'll leave it there. Hopefully that all made sense. And in the next video, I will work on part 2 of this question. All right, tick boom.